zap that laser at a rock, create a plasma from that rock, and then analyze what's in that and decide whether it's worth driving over there to look at it. The main REMS is actually an instrument that provides meteorological data, wind speed, pressure, temperature, things like that. We had a question earlier about meteorology. We're going to measure it directly. Just like we had a question about radiation. There's an instrument on here called RAD that measures the radiation at the surface of the planet. So we will get our first really good solid data set for that. And then inside is really where the hardest working and the most complicated instruments are. And essentially we've taken a chemistry laboratory and we've squished it down into a couple of small boxes, stuck it inside this rover, and the arm is going to actually drill holes in rocks and move that material into those chemistry labs to understand what's in that. The whole idea is, you heard the word earlier, habitability. Big long word for, is this an area that could have been a habitat or is it a habitat? That's the key. MSL is the scientific transition mission from understanding the water cycles on the planet to understanding if things could or could have survived on the planet. Next slide, please. To get to the surface, though, it has an atmosphere. Some of you remember, many of you remember the Apollo programs. Everybody remembers the Shuttle program because we're still doing it. That you have an atmosphere you have to get through. Mars has an atmosphere we have to get through. So getting things from the top of that atmosphere to the surface safely is a big challenge. And as Marcello had mentioned, many of us have tried, and the U.S. hasn't been successful every time either. The success rate for everybody on the Earth trying to get to the surface is in the 60 to 70% category. So it's really a tough thing to do. Just enough atmosphere, you have to worry about it. Not enough atmosphere to help you, like here on Earth where it's nice and thick and you can slow down easily. These are the pieces. The thing on the top is the cruise stage. That keeps the spacecraft and everything alive, provides power and other support systems on the way to Mars, which is about an 8-month journey. The top white thing, just below the cruise stage, and then the dark thing at the bottom are the aeroshell. So just like the old Apollo capsules, the rover is encased, just like the astronauts were, in this device. And that dark brown thing, that heat shield, takes all the heat on the entry through the Mars atmosphere. The next thing down, looks kind of like a spider, is called a sky crane, or otherwise known as the descent stage. You saw it in Dave's picture or his video a minute ago. That actually is essentially a rocket-powered helicopter, and that's going to land the rover. And then the rover, which doesn't look much like a rover in this, is the next thing down. It's all folded up to be able to fit into this clamshell. I'm going to show you a video at the end of how all this stuff unpacks and walk you through it as we get to the surface, which is, in my opinion, probably one of the greatest engineering feats that's ever been actually invented. It's absolutely unbelievable when you see it. So next slide, please. I told you it was big. That's a Mini Cooper, and that's the back shell that I showed you. It was white in the previous picture, so you can see how big this is. As a matter of fact, the Apollo capsule, and there's one of those on the floor you should go look at, easily fits inside this, and you can close it up. You could probably put 6 or 7 astronauts in this thing, but we couldn't get them back, so they probably don't want to go. Next one, please. This is the inside of the rover. So the rover looks nice, got 6 sides, excuse me. You know, looks like a nice box. There's a lot of stuff inside this. These are what we call the avionics. So these boxes are the brains of the thing. The computers are in there. The power control systems are in there. Because of the temperatures at Mars that you heard from Jack and Steve about, there's heating control systems in there. There's batteries in there. And then this has a small nuclear generator on it that creates heat, and we use that for both heat and energy. And the control electronics for that are in there. That big empty cavern in the top right is actually where one of those chemistry laboratory instruments goes. I'm going to show you that next. Next slide, please. This is 2 pictures from 2 different angles of the same instrument called Sample Analysis at Mars. For the students who've had chemistry lab, those are essentially a whole ring of test tubes there, and we have the ability to sample over 70 individual samples on the surface of Mars. So we're going to have a drill, and we're going to drill holes, we're going to process that material, and it's going to come back and go through all these different chemistry steps in this device. This is an amazingly complicated thing. This usually will be a couple of stand-up racks in a chemistry laboratory, but we've crammed it down into this little box that's about this big inside MSL, Curiosity rover. Next slide, please. And this is what's going to do the drilling. This is a complicated looking device because it actually is. On the right end, you'll see two fingers sticking out. In between those is the drill itself. On the other side, I'm sorry you can't see it, is actually the processing system that will sieve and will sieve the material and route it around and get it into the rover body itself. The red box that's facing you is actually a device to take clean dust and things off of rocks so that you don't sample the surface dust. You actually are able to sample the rock itself. And then just behind it, there's a little black box with a big silver-colored cable that goes into it. That's a microscope. We call it a hand lens imager. And so that's another tool that we'll use. This weighs about 100 pounds, and it's at the end of a 6-foot arm. So it's quite a piece of engineering to make this guy work. Next one, please. This is actually the descent stage, or the sky crane, with the rover wrapped up and packed up underneath it. You can see one wheel in it, but I want to show you that because I think the next slide is we're going to go into an animation. I'm sorry, we have one more slide. Next one, please. This is the whole thing put together. I showed you the cartoon of it broken apart. This is what we call the stack. Every once in a while, to make sure everything works together, we put it all together and test it as a single unit, and that's the stack. If you look at the bottom, you can see little guys down there in their bunny suits, as we call them, walking around. So it gives you an idea how big this is. So the next thing I'm going to show you is an animation. And this animation is actually beginning at the top of the atmosphere. And this is how we get the Curiosity rover unpacked and to the ground. This whole thing is called the 6 minutes of terror. I have yet to learn how to hold my breath for 6 minutes. I'm working on it. I tried it on Phoenix when we did that in 2008, and I turned blue and it didn't work well. So we're going to give it another try here, but this is an amazing sequence. I'm going to walk you through it. So we start at the top of the atmosphere at about 12,000 miles an hour. As it comes through about the atmosphere, the heat shield takes up about 95% of the energy of getting to the ground. When we are around supersonic, a parachute comes out. This takes out about 4% of the remaining 5%. Heat shield comes off. The rover wheels come down. Wait for it. It comes out of the back shell. Okay? So the sky crane and the rover are attached to each other. So this is a rocket-powered helicopter now on the way to the ground. Horizontally, it's barely moving. Vertically, it's a meter or so a second. And now it's going to roll the rover down on a set of cables from the sky crane. It's now going to slowly descend. It's going to touch down. When it recognizes touchdown, and the rover is the one to tell itself that it's on the ground, it'll cut the cables. Sky crane goes away and just crashes off in the distance. Don't need it anymore. Its job is done. Out of fuel, basically. Now we unpack the rover. So that sequence that you just saw in about 40 seconds is 6 minutes long. So it's because the light time, the radio time between Mars and Earth is around 7 minutes or 8 minutes, this whole thing happens before we even see it start. So we don't know the end until it's all over. So I'm going to let this run for another minute or so. You will see it drive off. You can keep an eye on this. It's going to actually show you how ChemCam is going to work, which is kind of fun. But this is the end of the presentations, and I'm going to open it up for questions. We got enough time for just a couple of questions. I think you were first.
If I look at the mass of the rover, what fraction of the rover mass, what fraction is the rover mass of the entire package?
The entry mass at the top of the atmosphere is a little over 3,000 kilograms. And the landed mass, which is the rover and all the instruments, is around 970 kilograms. So it's about a 3-to-1 ratio.
If you were to do aeronomy on the surface of Mars in this future exploration, have you considered the use of UAV-style devices to help you sample different layers of the atmosphere? Is that part of the planning? Is that considered?
Many things have been looked at, and I'll let you answer part of this. Yeah. But I mean, we've looked at balloons, and we've looked at Mars airplanes and things like that. They're difficult to inflate because not enough air for propellers and jet engines and things like